Korea. He served as a senior editor of blockchain technologies in Springer Nature, IEEE Computer Society, an ACM distinguished speaker, a senior member of IEEE societies. Thank you so much, Professor. And now stage is yours. Please go ahead, sir.
Yeah. Thank you very much, Professor Ajay, to introduce me nicely. And thank you very much, Professor Rajput, that can you giving me this opportunity to connect with you, and we're going to present and talk this topic.
Yeah,
thank you. So, yeah, so my topic was the blockchain technology for connected vehicles. That connected vehicles, we can say that that is a more self-driving car, and we are going to how to implement blockchain technology in this autonomous vehicle field. So those things I'm going to talk about today, and there the vehicles communications related things also is going on nowadays. A lot of vehicles we have the advanced vehicles, they can continue, they can communicate each others and following the messages, sharing the services in things, but that means they have generated a lot of data. If there is a lot of data, and because this vehicle communication, that is the mobile based, like mobility is there. So during the making the security, making the protecting the personal information and vehicles informations, what going on the during the some particular reason, so it is a very important. So for that purpose, we have trying to use the blockchain technology. We have introduced blockchain technology for that vehicles communication things. So this is my contents. I'm going to just introduce about the what is the exact blockchain technology, and after that how to blockchain into technology can be used in automotive applications, and what type of research is going on worldwide. So those things will discuss here, and then we are provide that I'm going to provide that blockchain technology solution for autonomous vehicle, especially for the communication purpose, and applied scenario for the blockchain technology solutions. And then we discuss about to the blockchain technology intelligent vehicle intersections things. So we have did simulation based on this our blockchain technology in the intersection scenario use case. So after that we discuss about the more simulation result about to these applications. So what is the blockchain technology? As we know, like 2008 we had the huge crisis, financial crisis in worldwide. During that time, that is the that Satoshi Nakamoto, who is from Japanese guy, but till now nobody found him. Who is that guy exactly? So he introduced this crypto things like Bitcoining and those cryptocurrency in the world. So after that, like blockchain is they are using to, like nowadays we have heard about the Bitcoin, right? Bitcoin is going to very boom. Nowadays is around $60,000 for one Bitcoin. It's going on. During that time, 2008, and during that time, nobody can be imagine that this much price gonna be happen, and we are going to liable on that type of online and cyber virtual currencies things. So those currencies is famous, and that type is getting the boom because of this backend services, that is blockchain technology. This whole Bitcoin and cryptocurrencies and virtual things, virtual currencies are working based on this blockchain technology. So blockchain is a disruptive technology that emerged into late 2008 in the midst of the global financial crisis. It comprises the unchangeable digitally recorded data in the packages and called blocks. So these digitally recorded blocks are connected to each other. So if you have some informations there, so nobody can be modified except like without permission about more than 51 percent permission about that network people, network users. So these digitally recorded blocks of data is stored in the linear chain, and this each block in the chain contains data that is cryptographically has. So as a study, they mentioned that they have taken around 2040 till 2040 is going to Bitcoin going to be mined. After that, that Bitcoin mining gonna be completed. Nobody can mine the new. Nobody can create a new blockchain, a new Bitcoin currencies like cryptocurrencies things. So now, what is the exactly this blockchain technology? As they discuss more cryptocurrencies and those things. So as I mentioned, these cryptocurrencies and virtual environment is based on the this blockchain technology. They have basically four specific features like consensus, digital distributed ledger, cryptocurrency. For the cryptocurrency, they are using the hash and then smart contract. So consensus is the providing a making the some mutual agreement between the users or between the network members or node, we can call that those nodes, if they are agree some particular transmission or particular transaction what is going in the within a network, then it's going to be like more than 51% people or 51% nodes are agree with any transactions, then it gonna be happen, it gonna be transaction gonna be successfully involved, successfully execute in the network, otherwise it's not gonna be executed. Second, we have digital distributed ledger. So each node who is involved in the network, they all going to be a store in the their each system. Like for example, if I am the one node member, so I have a same information what else have information by the others node in the or other members of the network. So they had digital distributed ledgers. Third, we have to cryptocurrencies, cryptography, that is we are using. So what is the cryptography? What we are using the hash function. They will use for the multiple multiply with the alphanumeric and special characters and generate the hash function with the nonce, some specific nonce. They have a shine, and according to that, they will generate the each transaction going to be to generate the new hash ID who for the who is involving in the network, that things. So based on those calculations, there will other members uh, gonna be verified or gonna be agreed. Sorry, other members cannot be find it the who is exactly this ID, because every time is changing the ID, right? Second, we have to smart contract. That smart contract have means like if who is involved. Like for example, if nowadays is a mall culture we have, we going to mall and we going to purchase there, right? So if in the we go inside of the mall, we are not going to do the bargaining things. Okay, you take this money, and like bargaining is very famous in our country, like the going on. So those things in the smart contract is mentioned. If you are agree about this something, then you can be join us. If you are not agree with this rule, then you don't need to join us. That is the making the some smart contract, and all members must be the joined, must be the signed by those smart contract, and then after that they can be inside, they can be comes inside of the network, inside of the that blockchain network, otherwise they cannot be allowed. And when they are coming inside of the network, after that they cannot be declined that to doing anything, or they can now be declined for the leakage, leak the any privacy of the network, and they all things are mentioned in the smart contract things. So these are the basic idea of the blockchain. So blockchain is a type of digital distributed ledger. So a type of distributed ledger designed to record digital interaction for purpose of transparency, efficiency, and is also added the security thing. So, like we have to consensus, that is replicated, shared, and synchronized digital data that is geographically spread across the multiple sites. There is a no central administrator or centralized data storage. What data I have stored, the same data can gonna be stored by stores by the others in the who involved in the network things. So that is. Next, we have to the characteristics about the blockchain. We can consider a distributed ledger technology as a parent and parent technology of the blockchain. There is nevertheless not all distributed ledgers are the blockchain. These things. So blockchain technology provides a peer-to-peer network without interference of the other third party. So these are the basic features of the blockchain network. So all blockchain technologies are indeed a type of distributed ledger, but not all distributed ledger are the blockchains. So as far as the architecture behind the blockchain technology, it is peer-to-peer network without, as I mentioned, without interference of third parties. So now we discuss how can we use this blockchain in autonomous vehicle, or not exactly autonomous vehicle, any advanced vehicle who has the capability of to transaction and communication with the other vehicles. So clearly we can say that there are several characteristics of blockchain technology that is lend themselves to the autonomous vehicle everyday for the everyday use. For example, they required why we required this blockchain for the autonomous. We need to find out the safety culture for the vehicles and security cultures. This all mix can be we can get it with the help of this blockchain technology. So the pinnacle is the accomplishment of the merging of two industries is the development of the safe autonomous vehicle. So that utilize the security characteristics and offered by the blockchain. This promotes the safety, which is the paramount, the prerequisites in the automotive industry. So let's examine and further compare to this traditional security offered by the information technology and automotive industries. How can we do it? So first, let's we talk about to the automotive industry and automotive development. What is going on all around in the our vehicles and those things. So as automotive technology development, that we can know or we are imagine that these are the going to level 6 level for the upgrading. So in the first level there is a no automation and completely we have the manual or manually vehicles. Then we have to driver assistant, we get it the driver assistant, then it will be increased for the partial automations. And for the electric vehicles, those in level 2. And level 3 we can conditional automations features for the vehicles. And level 4 have high in automation, that is currently we are belonging somewhere in the conditional automations and high automations things. Sometimes some vehicles are coming like that way, but we have still need to wait for the fully automated vehicles. So this is the we can say that it using the ADAS, like advanced driver assistance system. Their human driver monitors the driving environment, and for this can be happen with the help of this ADAS. And in the automated features that is belong from 3 to 5, there is an automated driving system monitors the whole driving environment for the all around the vehicles, what is going on the road, what is there, and what is inside of the vehicles, who is sitting and how is the position and those things. This all is coming from the automated driving vehicles. So this label has defined by the Society of Automotive Engineers, SAE J3016 standard, and they are approximately believe that till 2030 automotive technology will be the fully autonomous, as approximately 20% of vehicles in the world they're gonna be fully automated things. So as we discuss about to the when we are nowadays in we are conditional and high automation field, so there is a lot of communications things is going on. So we can our vehicles can talk to each others to how can be what is the going on, where is the services, some petrol services, any type of services, any accidents happen, then how can we manage those things. So that is the whole vehicular network is required for those security things. So for example, there is the two vehicles, they are communicating with through the mobile and through the cloud servers. So they have communicating with mobile Wi-Fi upload hotspots 802.11. These are the standard 3G, 4G, or 5G nowadays. They are using things application for the communication purpose, for the communication with the one vehicles to another vehicle or one vehicles to their services. To and DSRC, dedicated short range communication, that is roadside infrastructure. They are using to ITS, intelligent transportation systems. They use mostly vehicle to infrastructure communication field. Consumer network, they have required to home and dealership Wi-Fi hotspot, that type of some communication things, communication channels. And then we have to electrical charging network, that is charging station and other services. So these are the communication way or These are the some communication where how to communicate with the vehicles and where they are going to communicate. They're going to communicate vehicle to infrastructures, or vehicle inside of the vehicle. They are sharing the information, sensors sharing the information of vehicles informations. Sorry. So they are making that all information is going to communication services provider, that is fog and smart grid, energy service providers. So this required to security. So why my means is introducing this communication channels and those things. It's representing that we need a security, we need the protection from the each and every level. For example, in the vehicle to vehicle, from here vehicle to communication channel, during the communication channels, through that there's also required the security. Through the cloud server, do the some communication things with the help of other field. We asking about the some subscriptions based services, subscription based like private or OEM cloud, enterprises cloud. So this all required for the service purpose. So there each and every level we need to protect our vehicles. If we have a leak anywhere, we gonna be lose, or we gonna be we think that, oh, there is a not important for the security for this location. So it is very big vulnerable for the vehicles and for the people's life and people vehicles too. So that is the vehicles, about the requirement about the cyber security and protection things. So now I'm comparing where is the traditional protection and blockchain protection. Like traditional security protection means it's not about the vehicle, it's about to the where are the we require the protection for the our information data safety, data security, and for the any vehicle security, any device security. So we required anywhere. So what is the issues for this traditional security protection? We have the centralized architecture, heavy on the resources. We require a very lot of resources that can be provided to protect our these vehicles. Then we have to unable to protect data that is mobile, unable to handle large amount of data that at the same time, because vehicles are communicating each other and sharing information. So they have lot of data generation, right? Data generated. So how can we manage this huge data? Because the vehicles are moving and they have a mobility feature, so they cannot stop and cannot manage, and they cannot watch on all things. So that is the one issues in current traditional security protection. We have to know access to vehicle history, and know we like access to vehicle history means like if something happened in some information is misguided by the vehicles, then it how can be gonna be managed, how can be is to going to we can verify that this vehicle send the wrong message, and because that vehicle is sending wrong message and they move from another place. So that can be also issue. How can we manage those things? So how can we do that things? Okay, so that is also one issues. Another, no distributed network. Like we have to ITS system, that intelligent transportation system, all is controlled by the some central organization or road organizations from the government or from the other places. So these are some protection, some security, traditional security protections. They have some this of issues. How can we blockchain will provide to solve these issues? So as the name we mentioned, that first is a decentralized one. We have to low on the resource, just one blockchain server, a blockchain network. They can be provide the whole informations. We don't require to separate informations things. Able to protect data that is mobile, with their mobility data they can protect by themselves in the through the blockchain network, and able to handle large amount of data at the same time. As we know that blockchain as the we using the huge server, so based on that we can say make it we can manage to haul large amount of data, and it is access the vehicle history as much as in vehicles are moving, but their hash ID and their information is already stored in the blockchain. So we can do that things. We can trace the access the history of vehicles, what they are sending them,
colleagues.
sending the messages, and so these things. Second,
Uh,
we have
Professor Madhu, you had
yes,
some meeting at 9:30, na?
yes, sir. So we have 4 minutes
So
more.
whenever, ha. So is that online or this is an offline
It's a,
meeting?
no, it's online.
Online meeting. Okay,
Yeah, yeah.
okay.
So I'm not
So
moving from
whenever
my place.
whenever you have to leave, quickly, you can just inform me, right?
Yeah, sure, sure,
And
yeah,
then you can join back.
yes, sure.
Okay, okay. Go ahead.
Yeah. So yeah.
Hello, Professor Hassan. Are you?
Oh,
This is
good,
you.
good.
Everyone, please keep your microphones muted, huh?
So this is from my side, not because
So sorry.
I joined that meeting in the Zoom links, so I opened the Zoom. That's why.
I will be
Okay,
back.
okay. So
Sorry.
you carry on with your meeting, right? And so in this meantime, I will be discussing some more aspects which I had missed to discuss last time, right?
Yeah. So
And
I just finished this slide, and after that I'll go for the
correct,
meeting.
correct.
Yeah. So yes, as we mentioned that this blockchain technology can be provide the distributed network. So that is the traditional security versus blockchain protections. But in the vehicle point of view, how to we our blockchain can be manage things. Blockchain technology going to be protect to our vehicles. So in the traditional security protection, we have to centralize architecture, heavy on resource. These are the similar things we have in the security in the traditional way. And our security in the blockchain can be protect, as I mentioned. We have to decentralize architecture, the low on the resources, and able to protect data that is mobile, and handle to the able to handle the large amount of data, because the blockchain network as much as server is the bigger, so we can store as much as data, and then we can use those data to find out the what the spell they are using, misbehaving, or any vehicles information, vehicles history on there. Then we have to the access to the vehicle history and distributed network, vehicle access to the vehicle history to find out that which vehicle, like some vehicle has some accident and they are hidden, they're going to sell on the vehicles to for the resale in that purpose. So people, buyer can be asked about to the what is the history. Some people say that no accident history, nothing missing, nothing else, nothing happened, anything. So they are have some issues. So they can be we can be access that vehicle history from the our blockchain server, and we can show those things to reseller, to buyer, and buyer can be satisfied what is going on. So okay, and then we have
Hello,
distributed
Professor.
networks. So
Hello. Hello.
okay, that's the slides, and after
Hello.
that I will come back,
Hello, nice to meet you.
rejoin the meeting.
Actually, meeting you for the first time.
That's right.
Professor Raj, can you handle this thing?
Okay, I will continue the discussion. Okay,
Thank
you
you.
just come back after finishing your meeting.
Yeah, thank you, thank you.
Yeah, hello everyone, all the participants. Professor Madhusudan has some urgent meeting, so he is dispensing that meeting through online method itself, and after that we will carry on. So, dear participants, I would like to share with you all regarding the features and patterns which we develop. And in this connection, I would like to talk about uh, features in gas sensing systems and how they work, right? My primary interest is whether If we have some objectives, for example, air quality monitoring, or I can say vehicular pollution monitoring, air fuel mixture monitoring, breath analytics, detection of a specific gas, right? So nowadays you might have observed that monitoring the air quality has become very important these days, right? In fact, in the air quality monitoring, we have multiple parameters to multiple gases to take. The first is carbon monoxide, then we have NOx, then we have SOx, then we have PM 2.5, PM 5.0, PM 10.0. In fact, PM 1.0 is also considered for observation, right? So one question is, how do we monitor various gases, right? So that is the challenge. So let us think about these parameters, and based on this is something which is very typically theoretical concept based on which you can actually work. So the very first thing is, let me have a substrate, or I can say non-conducting base, right? Usually it is known as substrate, we call it, right? So on the substrate part, what happens is that we deposit thin film of semi-conducting material, right? So usually SnO2, tin oxide, is one very good basic semiconductor material which can be conveniently deposited on a substrate, right? So this substrate is non-conducting substrate, so you can conveniently deposit this material, right? So now once you have deposited a semiconductor material, and then we heat this semiconductor material with some heater supply. So what we do, we usually heater usually in the range of 250 degrees centigrade to 350 degrees centigrade. So this is the temperature at which this non-conducting base has been heated. So So this is at a very high temperature. Now, while it is at a very high temperature, now if I expose this base, this sensing material with air molecules, gas molecules. So if we expose this with gas molecules, they will strike, right? And while they strike, they will share their electrons, right? And in this meantime, they will strike and go out, right? So what happens? While it comes, strikes the base, sensing base, and then go off, there can be two processes which can happen. Absorption or adsorption. Absorption means creating bond, whereas adsorption is just sharing electrons. So what happens? As these electrons are shared, the conductivity will change, right? Because of the more electrons. Since it is a semiconductor material, with the presence of electrons, you can induce more conductivity, right? Or make it less conductive, depending upon how many electrons have been injected or have been shared. So can anyone tell me when would I receive more electrons if some gas flow is coming, right? So can anyone tell me how many electrons would be there if the gas is thin, or would we get more electrons when the gas is thick? Anyone can answer. Dear participants, please tell me if would the number of electrons be proportional to the concentration of the gases which are coming in? Right. This is what I wanted to listen, right? So more electrons means more gas, right? So more electrons means conductivity, right? So which is inversely proportional to resistivity, right? So what happens? Change in resistance is inversely proportional to concentration of gas. More the gas will be exposed, more electrons would be there, and your semiconductor material will be less resistant. So usually, usually what happens if I say that this is the concentration, percentage of concentration of the gas, right? And this is the usually the percentage the change in resistivity we measure by means of percentage change in resistance.
So sorry, Professor, I'm here now.
Yeah, okay. Hi, Madhu. So could you complete your meeting?
Yes, just complete.
Yeah, okay. Just give me 1 minute to finish what I had started. Right?
Sure.
Right. So, dear all, now you see that the concentration of the gases will show more change in resistance. So what happens if I say that this is 1% concentration, this is 2% concentration, this is 3% concentration. So accordingly, the resistance usually changes like this, right? Sometimes some sensors may show it like this. Some sensors may show very less change in resistance, right? So that was about the gas sensor systems, how they produce signal in terms of change in resistivity, right? In fact, this is the basis of pattern recognition for gases. So even if I want to measure the air quality, right? First of all, air quality measurement will be done through air monitoring sensors, gas monitoring sensors, right? And this is how it works. Okay. Now Professor Madhusudan is back, so let him continue. Okay. Welcome, Professor. Please.
Thank you. Sorry to this disturbance. First, I have some that's important things. So yeah, we are here. We're talking about two traditional. Can you see my PPT, right? No.
Please share your screen once again, huh?
Okay.
No, your PPT, your screen was visible to us. And the only thing was you can choose screen 1 or desktop. Yes, now your PPT we can see.
Okay. Yeah. So we are here. We just I just mentioned to what is the traditional protections is security protection in the current time vehicles, and how can be blockchain gonna be changed and blockchain gonna be make it more advanced feature, advanced security protect the our advanced as much as advanced vehicles. So as I discussed that we have to centralize architecture, heavy on resources, unable to protect data that is mobile, unable to handle large amount of data at the same time, and no access to vehicle history and the distributed network. So we can, through the blockchain technology, we can protect the we have to, because the blockchain has a decentralized architecture and it has a very low on resources. Just we need to store the information, and we can change the cryptographically is cryptography can be changed according to our applications. So and able to protect data that is mobile. So for that purpose we can also protect, because the all information is going to store as a cryptographically, so nobody can be accessed, nobody can be modified, changes the informations, and they cannot access the our personal informations from the vehicle vehicle's personal informations. Second, we have to able to handle the large amount of data at the same time. That has the, like, as we mentioned in the these are the mobile vehicles. Vehicles are mobile, they are generating mobile data, and they are moving one place to another places, and there has a lot of a lot of data generated at the same time. So many vehicles are generated similar data. So then how can we are make that this our vehicles through the blockchain network, we can protect those data as huge amount of data. And is access the vehicle history, as I mentioned, like some vehicle is gonna be resell, and that not gonna be access due to there is, if gonna be resell, so then seller cannot disclose their previous history, that is black history, that cannot, they don't want to show to vehicles buyer. So through the blockchain network we can access those all informations things, not information, but we can access, there is a reputations of the field of the in the environment, in the communication environment, in a vehicular environment, and then according to that we can say, we can buy, we can make the price, fix the price according to that. And as I mentioned, these are the distributed network, so all data has a distributedly, they are sharing each other's things. So that is the differences, and that is the comparison between the about traditional and blockchain protection. So how can we, like as I mentioned in starting, the blockchain has the four basic things: consensus, distributed ledger, cryptography, hashing, and smart contract. So how can be those features, or those four features going to be provide the security or provide to protection to our vehicles? Let's see. So for the consensus, we have all parties agree to network verified transaction, and it for this process we have to trustability, increase the liability of the vehicles and their data, their information, what the information broadcasting in the network. Sorry. So and authentication and authorization, so who is sharing information, particular information with the hash id, they can authenticate, and with the, there is a mathematical, as I mentioned in the consensus, is how it execute. Once any vehicle or any node is going to broadcast that, okay, I want to be know where is the petrol services, petrol pump, and then how then when it's saying that, with that he put it the some information, some mathematical problem that going to be solved by the other nodes, and when the other any node is, or any other vehicles he solved the problem, then he can say that, okay, is this message searching petrol pump is the coming from the some legal vehicles. So that vehicle the other who solver, that is called the miner, they will provide to the location of the petrol pump, and when it's sending the location, so who is the broadcaster who is looking for the petrol pump, they will share some message, some coins, that is the in the real life they are using the bitcoin, but in this case we are using to the trust point. So they gain the some trust point and find it the, okay, this is the giving me the legal answer and right answer, so that's they are following, and they make the authentication and authorization based on the this trust point things. Second, we have to distributed ledger, that is the append only system of record shared the across the business network or across to the vehicular network. So with this it will be make it the availability, retainability and traceability features, we can find out that things. Uh, then third, we have to cryptography, it is cryptography, they ensuring secure, authenticated and verifiable transactions, they will make it confidentiality, data encryptions.
Hello, sir.
And
Sorry to interrupt you. I think your screen is not visible to us.
Oh really? Now
I don't think. I do not know. Is it training and learning center? Are you there? Teaching learning center. Can you see the screen? Yes. Now it is coming, sir. Yes. Okay.
Now it's coming.
Yes, sir. Okay. Everything is okay now. Please go ahead, sir.
So can I continue here, or can I go back?
I think if you can go one slide back, that would be enough for us. Yes, sir. Yes, sir.
Okay.
Yes, yes, sir. From here. Yes, sir. Thank you.
Yeah, as we discuss about this again, so here we are showing the comparison between the traditional security and blockchain protection. So as a discuss our things like blockchain protection be is by the definition decentralized architecture that mimics the vehicular environment, and the second, they have a low on resources since one blockchain server can manage the entire system. Third, we have to the able to protect data is mobile because it is decentralized, and The resources are distributed through the vehicle communication environment. And like fourth, we have to is able to handle large amount of data at the same time, because data is stored in the blockchain server. So they can manage, we can increase or upgrade scalable data, scalable server, so we can increase those informations server look our data as much as we want. So and last we have to the distributed, so it has access to the vehicle history because of peer-to-peer real-time communications things, and all the data is stored in the distributed network. So next we have, as I mentioned, these are the examine. Let's examine that what are the relevant blockchain characteristics that are important to autonomous vehicle or our vehicle communications safety. So in blockchain paradigm, as mentioned, like all parties must agree to the network verified transaction. So therefore, that is shared across to the business network. Sorry. Therefore, they have all parties verified. That is the consensus. So it will be make it the trust. It will be in make the trustability, increase the liability and authentication and authorization. Then we have to append distributed ledger, that is append only the system of record, share share the across business network. That will distribute ledger is provide to the availability, retainability and traceability features that can be accessed some any points. And then cryptography, that's ensuring a secure, authenticated and verifiable transactions. This cryptography will provide the confidentiality, data encryptions, integrity. There is a point out that there is no any modification of the data. Then terms embedded in the transactions, that smart contract. In the last one, that is the smart contract, is provided to the terms and conditions to embedded in the transaction database and executed with the transaction. So it will be smart contract will provide the trust, that negotiation process and final contract and trustability and non-repudiations things. So that is the four features can be make it the whole communication vehicular environment or vehicular communications to completely secure and protectable from the data privacy, authentication, authorizations, data confidentiality, data encryptions, and availability and retainability of the data. So let's see. So this is the blockchain communication environment. We can say that they have all blockchain server can be used in the different communication environment for the vehicle to everything communication environment, vehicle to vehicle communication environment, vehicle to infrastructure environment. So this blockchain server can be handle the whole type of any type of communication environment of the vehicles. So for that purpose, this one we have to did the this patent also, that patent in the Korean patent, we did these things. So now we have to what the blockchain technology solution push. They are utilizing the same basic road and highway of the infrastructures. So if we using the same basic roads and highway without to changing any things, without to changing or modifying to the infrastructures, without to making the some burden to government and any others. So there's how can we get it the more better results for the this autonomous vehicle things. So the motivation for this autonomous vehicle is very strong, as we can increase the number of passengers, increase number of passengers, increase the amount of goods, increase the average speed, and we can protect, decrease the congestion, decrease the accident crashes, and decrease the carbon footprint. And it will be provide that seamlessly transportation without the any issue, without to any accident, any congestions. We can use through the blockchain network. We can be protect securely and safely. We can make the transportations. So what is the process of this blockchain one? So for example, if we implement blockchain technology in a autonomous vehicle, so or connected vehicles, then we can say that is vehicle, they have blockchain enabled this autonomous vehicle. That is a sender, he want to send some information or he want to require some information. So it will check make the blocks, store in the blockchain, that information, plus it has going for the crypto hashing. There is a transmission using the distributed and validated features in the network, and from here there is a blockchain server. They will store in the cloud, regular cloud, and their receiver will be received the information. So data transmission is committed to the blockchain and miners are rewarded. So these servers, or we can say that these servers have some huge network, huge region area, and from there is a multiple vehicles are there. They can be verified this information and they can do the minor things, minor mining things, and they will get the some reward. So here vehicular cloud is the hybrid technology that uses the vehicle resources such as computing, data storage, internet decision making based on this blockchain network. And we have to a miner is a blockchain enabled vehicle that can validate the data transmission in the network. So these are the whole process of blockchain technology, how can be execute in this vehicular communication within the blockchain network. So for example, we have to do miner, we talk about the miner. As a previous slide we said that miners are rewarded by the senders, right? So explain what is the reward is it is called. So in here we are introduced for the vehicle purpose. We have introduced, we didn't use the Bitcoin and those cryptocurrencies. We have introduced their intelligent vehicle trust point. That trust point we used to be as a reward to one vehicle which vehicle has doing the mining in the network. So for example, that is the sender and that is the receiver. Between that they are doing the mining things. So we are giving the some alphanumeric those rewards to that vehicle who's verified this transaction, and they will use it that IVTP or this trust point as a say as a their reputation points, we can say that. So the IVTP it stand for the, like we talk about the intelligent vehicle trust point. This consists on alphanumeric numbers that represent a crypto ID. A crypto ID is used to establish the trust in the entire network among the vehicles, and infrastructure and vehicles to vehicle communication. So this crypto ID is a different every time it is the transmitted and is used reward to all those vehicle that are doing the miners, that are the miners. So the vehicles with the highest number of IVTPs is the most trusted or most trusted vehicle in the network, and the more data mining of the vehicle conducts in the network that are more rewarded by the other vehicles. That means what how as much as any vehicle has the IVTP, this trust point, that vehicle's reputation in the network or in the uh, that vehicular environment that has a very high. So for example, if someone is going to resell their car, their vehicle, so if they don't need to show the history and those things, they just show that how much trust point he gain, and based on that trust point we can use this IVTP to multiple purpose. For the we can use for the services, they can be get the some discounts for the services, they can use for the insurance. So in the insurance nowadays what we are doing, we for the if we have a vehicle, we are going to do the insurance for the whole year, even though we are not driving the whole year, we are just driving 6 month, 8 month or 9 month. So based on this IVTP transactions trust point, we can bargain and we can claim that how much we are driving. We just show those data, and based on that, insurance company they can be refund us that rest of money, or they can be charge us to, other if that extended. So they can charge us. So based on that, this trust point has a multiple purpose to use in this communication environment. So why we require to these rewards to important? Because that intelligent vehicles trust fund, there's a blockchain secure trusted communication based on the blockchain server. So store the vehicle has ID and their information is IVTP, how much in transaction is happening. So they can communicate and during the and get the complete communication details. So based on this information, they can show to vehicles reputation in the like they can also detect the how much accident history is there, or any wrong message, or any uh, attacker like things they did the work. So this type of things we can protect with the help of intelligent trust point. So yeah. So for example, that is the blockchain enabled autonomous vehicle. We have communicating V2X, V2V communication, V2X communication, V2 vehicle to infrastructure communication. So blockchain server they will provide, they will store the all information about the VTP to vehicle has ID, IVTP and communication detail, and they will get it the whole history of the vehicles. And according to that, we can resell, we can claim for the product, and we can claim for the refund the money back from the insurance company, or any services we can claim for the services. So that is the multiple features for the using this blockchain technology and this IVTP in the autonomous vehicle or vehicular communication environment. So based on this, like currently I'm just talking about to blockchain technology and autonomous vehicle and things, but there is a lot of other project is going on. Those projects are based completely based on this environment for the blockchain for the vehicular environment. So they are using the shared driving blockchain. They are using shared driving, secure the vehicular communications, autonomous vehicle. They're using the for the privacy purpose. Blockchain using for the decentralized transportation system. Blockchain are also using to store vehicle uses information, transaction, fuel, toll, insurance, etc. And they are using for the ride sharing, shares, ride driving. So these are the some other applications going with the applications project and going by the other different organizations. So in there, I'm just showing that these are the some organizations who are working on this type of some project. So like UCLA, Toyota Research Institute, Big Chain Database. So these are working for the share riding, Oken Innovation. This is a Israeli startup company. They are working, and Toyota. So they are working for the ride sharing, JDF, MIT, Digital Currency Initiative, and Comrades. They are working for transaction, fuel, toll, environment, and for in this from here decentralized secure vehicle communication privacy autonomous vehicle and trusted vehicle communication environment. So we had the work on this through the with the help of when I was in Yonsei University. I worked at this all project this project from there. So we this seamless transportation lab they are working in the decentralized secure vehicle communication privacy autonomous vehicle and trusted vehicle communication environment. We have provided to focus on about to more in cyber secure automotive cyber security point of view, because why we are focusing that one, everyone is now focusing about to make the as much as full autonomous vehicle, right? So as much as the IT, as much as the computers, as much as the technology we are going to use in autonomous vehicle, that for the vehicle, so as much as there is vulnerability, so we are also need to start the thinking to how can we protect. So we believe that this blockchain has the one good options they can provide to they can protect to the as much as advanced vehicle is going on. So by combining this all available data, there's 8 area of focus with the organization working on them. We can see which project is getting the most attentions now. So now this is the blockchain technology for communication environment. As we see, we have using two local dynamic blockchain and main blockchain, that is the summary based event and LDB based event. So where these are vehicle is coming, they are is immediate data are they're storing in the LDB. If there has some event something happen, so they going on the blockchain and rest on going to overlap. So if only we could have self organizing traffic patterns when it comes to group of animals, there is a plethora of self-organized our system that can make our current traffic pattern seem simplistic and absolute when like swimming in schools, fish swim at the constant depth, slow down, alter course to avoid collision. That is the examples of to using this type of applications. So like birds flying in the flocks and low variability of speed. So these are the some applications examples how to we can use blockchain technology in that fields. Okay, so for example, this is our current traffic scenario, that is the without blockchain is going. So in this scenario, we can see that they are all based on the signal. If signal is red, yellow, green, then they are moving. But sometimes there is a lot of congestion, like lot of vehicle is going to some vehicle has accident, and this series accident is happened to be hurt by the so many vehicles together, right? So our traffic patterns today are far from self-organizing. So in this animation, we can see that the conventional traffic signals manage the flow of intersection. So, but drives make judgment calls relating to their speed, and when they enter the intersection, mistakes in the human judgment are made and accident is happened. Although not as a common conventional, but non-conventional traffic signals, but can be hacked for they can happen with the hacked by the other some attackers, the hackers. They can use the hack the this red signals and signal things and are modified their signals. So that type of things can be happen. So we need to protect those things. For that, how can we blockchain going to be help in this scenario? So let's see. So yeah, so in the blockchain, like vehicle is coming, they are communicating, and they all vehicle blockchain servers are communicating each other. They are transmitting what the vehicle is coming and what type of they where they are going. According to that, the self cars are control their speed and actions themselves. So in this animation, we can see that blockchain intersection there are no traffic signals of any kind. So each vehicle has unique ID. This idea is coming. So all its information, speed, direction, location, capabilities, etc. There's features, and we can say that state change are incorporated with the technologies within the vehicles. So when entering the intersection, the unique ID for every vehicles upload in the blockchain server, and hence the intersection becomes aware of every oncoming vehicles in the relation to the other vehicles. So already at the intersection, and the data received by the each vehicles and the determine whether it slow down or speed up, so it cross the maximum speed and safety. The blockchain data creates on the interwoven and self-organization system pattern. So that's the help to make it our blockchain is more self-organizing self-organizing system to for the vehicles can be control themselves things. So yeah, so here now what the now we have the issues, right? So because the vehicle doesn't have that much power and that much things they can control. That one the big issue, or maybe the everyone's minds comes to this question, like can be really make that powerful of vehicles? They can be changed, they can be controlled, they can be communicate to blockchain server, and they can generate real time data immediately and access those data things. So the question's answer is here. We have the laser can be possible, right? They can store the data. Second, we have to the hash function, that is block generation. So this hash function, what we did that we have like in the Bitcoin and other applications, cryptocurrencies and those big things, big applications, we have to very long length of the nonce, so that can be make it the more protect things, right? But in our case, we have to decide we can reduce the nonce. So we are not creating that much bigger length of the hash id. We are using the very small nonce with the hash id. So that's why it's create those data fastly. They can communicate very fast, approximately 0.3 per second, to generate the one hash ID, and they can be do the mining and protect the share the information within the network, within the vehicles or within the nodes. So we have this block generations. In the block generation, we use to Merkle tree. There is each transactions has the hash ID, then create the hash ID. They make the root hash, and it is the whole one block is creation. Then we have to consensus for that. We have using proof of driving. So like a normal blockchain and Bitcoin case and any other applications case, the we have to proof of work, proof of stack. So in that case, we have generated the new algorithm, that is proof of driving. They mentioned there's the vehicles are really moving on the road, not on the standing some one place, and they are just creating and generating the no generating the doing the mining and generating the trust point. So for that we have to use proof of driving for the using the nonce plus difficulties, how much difficulties we are using, and then we getting the result for the original proof of driving with the this information. If there is a assured the original proof of driving, that is the result success, that is the result. Otherwise there will be returned back through the blockchain station to there is that nonce or that hash ID is not working properly. And for the smart contract, we have to generate this thing to make the rules and some our conditions that who which vehicle going to be involved in the network and which is not. So if those are agree with that our smart contract and our conditions, rule and regulations, then they gonna be involved in the our network, blockchain network. Otherwise, they cannot. So that is depends on those vehicles. If they are not involved, so we cannot sharing there any communication, any information to that vehicles, and we can blacklist that vehicles. So they can be also cannot involve or cannot interfere to our communication network things. So that is done. And now yeah, so now as I mentioned that we have talking about two reward points, right? IVTP. So IVTP can be generated by the authorized organization or IVTP trust, or they can use by the center to issue unique cryptography. So they can exchange or they can generate based on to these things. So the traffic as a traffic scenario, the blockchain would not be possible without the IVTP access the method. So this IVTP can be understood as the reward point. The more IVTP of the vehicle has, more computational power expended. So by it will have a more points, making it more trustworthy. The initial IVTP crypto ID, unique ID, is issued by the some vehicle manufacturer or authorized dealer. So but they are generate, but they cannot find out the who their generating method, the unique hash ID generation mechanism. So that dealers are every intelligent vehicles when they are enter the network based on this initial IVTP ID, another new encrypted unique number is issued every time whenever they're doing the transactions. So thus this new IVTP is again an encrypted unique a number which is issued by the every intelligent vehicles by network and called the IVTP ID. So during the communication, vehicles are provided the rewards or more network generated IVTP unique number to build trust among the participants. So the vehicular network utilizing the blockchain enables services, user, data providers, manages and manages the generation and exchange these ever changing IVTP IDs. So now that we have to better understanding of IVTPs, we can better understand the seamless environment blockchain can be offer us. So that is the structure. How can we creating the block? So we can see, for example, we have the N block. is the current block of ongoing communication. So it has to be contains the block hash. There is a previous block hash ID and what the information timestamp when is the this block is generated, what version are the block generated, how many nonce we are using and targeted, where we are transmitting this block, and what is that message. So this all information will be stored in the one block. So for example like this, they have previous block hashes. The previous block hash can be more than one if blockchain is branched or all of them are appended. So timestamp, there's time when the state was generated, message information that vehicle wants to transmit to other vehicles, and version of block, whether a block was attempted more than one time or not. And this is the whole hashing is the transformation of string of character into the fixed length of value that represent the original string. So now we need to try understanding the state change. What is the state change? So the state, as I mentioned in here, there is a talking about to the generating the state was generated. So what is the state generation? So the state of changes for vehicle contain information about updates in the vehicle's position, velocity, acceleration, and inside a vehicle what activities is going based on the their all around two environments. So a state change contains the following four fields. First, they have unique ID which randomly generated in order to avoid the mining similar block. Second, we have to timestamp donate denotes to note when the state was generated. And third, we have to the position contains the location of vehicle including the direction in the which the vehicle is moving. And last, we have to the state change type records various times including information on start, acceleration, braking and turning, halting, reaching and a point, and magnitude of the action. So these are the understanding the state change of vehicles. So these four vehicles are included within the hash block, which must start with the specified nonce. Nonce means number of the zeros we are started things. So that's the overall concept for the implementing to blockchain in the self-driving car or any communicated network connected vehicles. How to they can manage. So it has till now. Anyone has any question? Please ask. No questions? Okay. So I'm going further. So we have two problems, so some challenges, not the problems. We cannot say the problem. We have some challenges for the when we are using the journal blockchain similar only one blockchain server in the network or in the vehicular network, vehicular environment. So yes, anyone has any question?
Sir, good morning, sir.
Yes.
Sir, can we connect sensor system with blockchain in healthcare?
Sensor system with the blockchain.
Yes, sir.
Yes, we can do that things. So can you wait for the my next lecture? I'm going to introduce two applications and some blockchain related application, those things. So I will
Yes.
talk with there. So if we are focused in this vehicle to here.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Thanks, sir.
Yeah. So I will actually next my next lecture I'm going to introduce to blockchain, basic of the blockchain things and their multiple applications. So I think there will be you get the your answer, and if not then you can ask. I will write it your question and then I will answer you. Okay.
Yes, sir. Yes, sir. Thank you.
Yeah. So in the about the vehicles, about the autonomous vehicle, we have to some challenges. If we are using the only journal blockchain or only single blockchain network or blockchain server for this applications, so they require lot of energy power, amount of power, consumption of significant amounts of power. It requires large size of data server to manage the information in real time. Storage of data needs to be stored for a long time, for long period time, more than 2 years things. And we have to management have issues or challenges for the management of data exchanged in the mobile and dynamic environment. So is it difficult to manage those things if we are going to use only one server. So we have solved that problem to proposed by the two blockchain server in vehicular environment. One as I already mentioned in my previous slide, there is a local dynamic LDB and main blockchain server. So how can we solve that one? So local blockchain server, we have used yeah. So we have to we have to use to two blockchain server, local blockchain and main blockchain technology server. So local, we have to dynamic blockchain server. They are update and upgrade auto self on self. Okay. And main blockchain server, as mentioned, that they are using to data as a event based, summary based of the data. So like we doing to two things. In local dynamic one, we have also implemented the block branching one. Branching is performed by local dynamic blockchain when the amount of traffic can be handled in real time. So branching process is governed by these equations, like delta T is the average time, is the average time which equals the summation of difference between the mining time and message broadcasting time over to the total number of vehicles. So for example, here we are for the understanding the branching process, we do the multi-branched LDB local dynamic process. If LDB has branches, a block has the possibility to be added in that blockchain. So hence making the process may run the faster, we can use this approach for the changing the make the for one data. If when there is we have a fixed amount of data, if they are going to increase, then blockchain LDB blockchain local blockchain server, they can be automatically divide in the separate make the branches. So a branch in LDB can only be divided into two child branches, not more than that. So this blockchain is used to keep track of IVTP transaction between two vehicles. So this operates in the way similar to a Bitcoin mechanism, both, but both in the Bitcoin universe and vehicular blockchain environment, we utilize the Merkle tree. So in the next slide, we are going to explain so about that. So when LDB recognize that the traffic has decreased and can be handled by a lesser number of branches, it can be merged two branches into a single branch. So a branch in LDB can only be divided into two child branch, not more than that. This blockchain is used to keep track IVTP. So as we already mentioned that both in the Bitcoin universe and the vehicular blockchain environment, we utilize the Merkle tree. What is the Merkle tree? We can explain here. Merkle tree is only contain the hash. It does not contain the transaction data. So they have only hash ID, Merkle tree, and they combine to two Merkle tree. They make the hash IDs things, hash ID, and then combining a more bigger hash ID, it make the root hash, and then it will be make the whole block. So next we have to the main blockchain is implemented by using the Merkle tree. There is a previous branching factor is greater than current branching factor, or previous branching factor is less than current branching factor. Then branching factor of parent, it is current branching factors to trivial cases, and one parent has the only one child in the main blockchain. We am talking about the main blockchain server. So that is the understanding of the minor thread of pseudocode. How can we do the pseudocode mining? So here we can see the function of minor thread. So we start if there is a nonce is true, the transaction is true. If it is mining, then if empty, then continue. Else they will get it the whole mining data and successful mined. We get the template and mine blocks and do the to mine and template and find out the successfully mining things, mining activities. So function miner thread runs from the starting of vehicle to its shutdown, taking care of the mining procedure. And the miner thread along with the mine block carry out the solution of the hash function, thereby generating the proof of work. And mind block will do the get template function, queries the local dynamic blockchain for the template list containing the information such as version of the blockchain, parent hashes, and so on other informations. And if we added the block function, simply send the mind block to be added in the LDB, subject to verify the proof of work. That is the consensus mechanism. So this is the use case we are going to talk or going to explain how to be verified, and we make that our idea are authenticated or useful for the network or not. For that we have using to this intersection scenario where we can see that 1, 2, 3, 4 vehicles are coming. We just taking the simple 4 vehicles and approaching the intersection. Now when which vehicle is going to move first intersection, going to cross the intersection, so we require the consensus between these all vehicles. So a consensus is reached regarding which vehicle has to earliest timestamp that associated with the block and associated with their transaction information transaction transmission. So the vehicle which calculates the proof of work or proof of driving the fastest on the IVTP, and the vehicle is allowed to move. After that, the same way procedure is followed for the other 3 possible more vehicles. So next we will show message broadcast time in the network. For example, these are the vehicles are coming. This is the whole hash ID block. Inside of there is a timestamp, there is messages, there is the there is state and whatever there is speed and all things inside of this message box block, and this by our vehicles gonna be received, and then they will find out the which vehicle is coming to these intersections. So for example, we have the timestamp now here. Each vehicle has the like vehicle 1 IV1, it comes time 4, that is 10:6, 10:2, 10:4, 10:3. So in here we can see that this vehicle is comes to fast earlier as based on the timestamp. So and based on that intersection scenario message broadcast time schedule by intelligent vehicles, we have arrival time, processing time, and then their vehicles to how much IVTP they have. And then based on this, they are changing the remarks, creating the remarks, and the processing time calculated for each step that defined can be seen here. You can see in here. So the time schedule of IVs includes the arrival time at the intersection and processing time, what the execution time it will take in, and then IVTP of the each vehicles, how much is IVTP. So in here we can see that this vehicle is coming first. So IV2 sends the start block start moving. So IV3 and IV4 send start block and start moving in this point. So IV1 send start block and start moving. So IV2 reaches intersection and IV1 mines the block. So it will be getted the mining block will be IV1 IV2, and IV4 reaches the intersection, issues the intersection block, and IV1 mines it but cannot move since IV2 is the crossing. So IV4 which comes second is now able to cross, and now IV3, which came in third, is now able to move, and IV1 mined this block, and IV1, which came in the last, it now able to cross. So it can be increase the IV1, IVTP of the each vehicles. So here arrival time we can see. So IV1 arrival, IV2 arrival time is earlier, and then IV3, and then IV4, then IV1. So they will move accordingly that purpose. So they are changing their reward points to each others. So increasing the reward point based on the mining, who did the mining things. So now here we're going to examine our test result. So from the various simulation analysis of applied the blockchain technology with this table is that benchmark at it is scaled the 5 levels of difficulties. So the zeros are the nonce. We are talking about the zeros are the nonce, and the more zeros and higher complexity, and the higher the complexity, the more time it takes for the system to complete the mining. So time on the right column is collected the seconds, how much time it will take to calculate this whole mining process. So if we are using to level 0, it will take 0.0045 seconds, and we have tried to average after 10 tries, 100 tries. So level 2, there is a we use the 2 nonce, there it take the 0.6705 seconds, and level 3 it will take a 0003 zeros, it will take 1.0383 seconds. And if as we increase, so we here we can say that that is the also time is also going to be increased. So in our simulation work we have did, so this simulation is done by our interns students. They came to here for the internship, so they had do with the level 3, we are using this level. So for this we had just, we don't have the system that real time intelligent vehicles or self-driving car, right? So we do this simulation in the on the computer. So the system specific requirement, we have all tests were run to the measure the time taken for the finding proof of work and proof of driving of different difficulties level by the system with the window like 10 characteristic of the start stated in that graphics things. So we have calculation methods. We using average time taken for mining analysis in the seconds by number of nonce, how much number of nonce we are using. So these are the level of congestion. We are used the single branch and multi-branch LDB process. So here see, yeah, so that is the intersection vehicles are moving together, and now they are start to be doing the analysis, doing the mining, and after the mining they are increasing, like level vehicle 1 they are stopped, and other vehicles are moving according to based as I mentioned by the previously slides.
Sir,
Yes.
sir, if you need a break or something, we can have, because you are continuously speaking for more than hour.
Is going to be completed, so I just
Okay, sir. So yes,
so
it's no problem, sir.
after that we can take a break.
Yes.
So if I ask that if you have any questions, please prepare your questions, so after the
Yes,
then we can take the questions.
sure. And those who have question, please drop your question in the chat box. So we'll ask you to ask the a direct question to the speaker, right?
Yes, so that is our simulation results. We, as I mentioned, that we have using the level 3 nonce, so 000, and it will take 1.03083 per second for the each mining process. So the beginning of the test seen here, we have phase 1 was run of the purpose of estimating the optimum difficulty level to be used by the mining algorithm as a proof of work, and all vehicles are approaching at the intersection and they are transmitting things. So as we already discussed these things, so here, so level in here we have defined that how to provide the IVTP and those things based on their processing time. They can be share the IVTP to each others, and then it generate the table and find out the which vehicle going to move first. So now as a simulation result we can see, so average time for the state change validation with the load of 22, we did the 2200 state change per minute. So according to that, we can see this is the branch one when we are not branching. So in order to blockchain to be a viable solution, it must be the feasible with the graph calculate the difficulty level of mining in the vehicular environment, and on the vertical axis we have to average time. This is the average time in seconds of the state change, and on the horizontal axis we have the time to second for the mining process to be completed. So based on these finding, it was decided that the difficulty level of 3 should be used in the more module, because this seemed to the limit the size of blocks without with the all three cases, so taking the approximately 2 to 3 seconds for validation of the state of change. So average time for the state change validation with the load of 2200 state change per minute in this here. And next, our next experiment we did the 2400 state change per minute. So here we can see branch 2 and branch 4. So if we have to branch 4, and then it will take how much times. Second, we have to the, this one is the 2400 state change validations. So that is the branch 1, and branch 2, it will take this average time for the state change validation with the load of 2400. So here we can see that there is a branch 4 is taking the first is going to higher, then after that is going to low. So and the other way we can say that if we have the low branches, then we have to highest data. So 14 seconds for unbranched LDB local dynamic data, 6.5 seconds it will take for the LDB with the n branch, only one branch, and 5.5 seconds it will take for the 4 branches things. So that is the last one. So when load is the increase, further the results obtained are even better. For the load up, this one is the 3200 state change per minute. So the average time of for the state change validation has decreased from around 23 seconds. So for that unbranched LDB to around the 16 second, and one branch LDB it will take around 4 branch LDB it will take around to 14 seconds. So however, branching comes with a drawback of high amount of duplicate state change lost in the block. So that's why we have to 16 seconds for the LDB with the one branch, 14 seconds for LDB for 4 branch. So that is the our simulation results when we did this simulation for the trying to implement this blockchain for our self-driving car in intersection environment, that things. So now we had to conclude, I'm going to conclude this talk. So as we introduce about to blockchain and how we had tried discuss to where in the how can we implement in the autonomous vehicle, and how can we be make it the any vehicle communications to make the more protected and more secure data and their personal information through the blockchain server. Okay, so blockchain technology, we provide the autonomous solution, vehicles issues solutions, applied scenario for we had discussed to blockchain technology in the what is the process and how going to be execute this process. And we use the use case scenario, that intersection scenario, and we discuss about to the our simulation result. So overall we can see we have find out the real, this is not the complete solution, but yes, these are the providing the very huge benefit, huge positive solution for the autonomous cybersecurity field, automotive cybersecurity field. These are the our references we had used in this during our presentations. So I want to just mention this idea when we are started, that idea we are first time we had presented in MIT like in MIT USA. So that time this idea going to be has appreciated by the very much from there. So after that we have to increasing branching and those all application. First we had just tried to implement blockchain technology for the intelligent vehicles, and when we find out their positive response from the MIT's professors and there, so we have into working on more and more that field. So thank you very much. Any questions? So please.
Any question from audience? So this is Korean, right?
Yeah, is a written Korean. Thank you for the in Korean language. Kamsahamnida.
So you know the Korean language as well?
Yes, some words. Yeah.
Okay.
Most for the communication purpose, I can communicate that thing.
Oh, that's good. So any question from anyone? Any participants? Just 1 second. So, sir, you also need to take the from 10:30 to 12 o'clock session as well, right?
Yes.
Yeah. So what we can do, we can have a short break so that you can also get some refreshment. Then
Yeah, sure.
maybe after 5 or 10 minutes we can restart it. Is that okay?
Yeah, sure. We can start from 10 minutes or 5 minutes, whatever.
I think 5 minutes. Yeah, 5
minutes.
minutes should be okay, right? After that we will have almost 1 hour.
Yes. So we will start from the what is there 2:11.
This is 10:43 over here, around quarter 11.
Okay.
So maybe we can start at 10:50.
10:50.
IST.
Okay. Okay.
Yeah. So there is a question. Let me just read it out for you.
Yeah.
So he has mentioned like, sir, if we want to study this paper, where can I find this one? Okay.
This paper like about to the branch based one, this all paper, this is published in the computer networks journal elsewhere, so you can get it the link there is a mention. Otherwise just send me the email, I will send you this, share this paper with you guys.
They can also go to your Google Scholar page as well.
That go for Google Scholars, or I have my research website reblockchain.org.
It's not working actually, sir. I tried to open it, but it's not working.
That one not working? Reblockchain?
Yeah, that I'm unable to. It's connected with your Google Scholar page, right?
Yeah.
But I do not know what is the problem.
Okay. So I'm just asking, this website is, how can we not working?
Maybe I tried to open it, but yeah.
Can you see this my screen?
1 second. Yes, but I cannot open it.
This link not open?
Yeah. So if you just go to your Google Scholar page, on the Google Scholar you have given the home page, right?
Yeah. So yeah, my home page is here, so you can use it one.
Okay. Okay, sir. So let's have 5 minutes break and then.
Yeah, sure.
Okay.
2:15 here now, 1:45, right? So we'll start to 11:50.
Is it quarter 11 over here? So I was thinking if we can start at 10:50 or so.
Yeah. 10:50.
Maybe 5 minutes, right?
Yes.
Okay, sir.
Okay. Thank you.
Let's have a 5 minutes break, then we can start again. Okay.